Hi, my name is Satyapreet Singh Yadav. I'm a final year MTech student in Department of Electronic Systems Engineering. I'm working under Dr. Chetan Singh Thakur in Neuronics Lab. Today I'll be explaining you about the MTech project that we have done, that is mmWaveRadar based multiple patient activity and localization. In this experiment, we are trying to localize as well as perform activity classification of human targets inside a closed room environment. This application is being targeted for healthcare sector as well as for monitoring psychiatric wards and in jails. For this, we use this tiny radar sensor, which is called IWR6843, which operates in the frequency range of 60 to 64 gigahertz. Now, using radar, it transmits electromagnetic waves which are reflected by human targets, and based on which it estimates the range, velocity and angle information of the human targets. Now radar has got its own advantages, that is, as you can see, it has come in a very small form factor and it works in robust environmental conditions, that is, it can work in low light, dark as well as foggy conditions. And the third major advantage is privacy preservation, that is, compared to other vision based sensors like camera, where the person who is monitoring the patient can actually see what the patient is doing, but here in the radar it provides you point cloud information, and hence based only on the classification, the surveillance person gets to know what type of activity the person is doing. And also the data that we receive from radar is very compact in form factor as compared to other vision sensors, and hence using radar as a wireless and contactless sensor for multiple human patient activity classification is of great advantage.
Hello, I am Kola Bharat. I am MTech second year student. I am in DSC department. I am working under Professor Chetan Singh Thakur in Neuronics Lab. So basically for the application that we implemented, which is multiple patient localization and activity classification, the radar sensor is mounted at the one edge of the room, which transmits the waves to the target environment of the room, and also the reflected waves are processed to calculate the range, velocity and angle information, which are used to calculate the range, velocity and acceleration information of the patients. So whenever there is a patient in the target environment, it detects the person and it processes the range, velocity and acceleration information, which is given to the 3-layered CNN, which classifies the activity of the patient, and also the position of the patient who is in the target environment is used to localize do the zone localization. Basically, to interact with the radar sensor that we have implemented Python based GUI, which is used to send the configuration information to the radar sensor, and this PC receives the information of the range, velocity and acceleration to do the classification of activity and also the zone. So you can see here, this is the target environment that we have considered. This cuboid refers to the chair region, and this cuboid refers to the bed region, and this cuboid refers to the bathroom region, and this portion refers to the main door information. So using this one, we'll send the configuration file to the radar sensor, and after receiving the information, you can see the person like appearing as a cuboid in this GUI, like wherever the person is. And also here you can see like if the person is present, you can see like what zone he is present in and what is the time duration he is there in that zone, and also you can see the activity being done by the patient. And we implemented this one for two people, so both will be updated simultaneously in case 2 people are present in the environment.
Now let us see a demo showing the real-time working of mmWaveRadar sensor for this application.
Yeah, so we can see that the person in the frame is walking right now, and in the GUI he is represented as a green cuboid basically. We can also see that the classification being done is over there is walk. And now because the person is come to rest, because of which the classification also comes out to be rest. Now because he is sitting down, the timer has started and the classification result also shows as sit down, and the timer also got launched saying that the location is on the chair and the given duration of time is also being recorded there. Now, because the person is at rest on the chair, the classification result also tells that the person is at rest. Now, when the person stands up, the timer stops, and the classification also shows that the person stood up and immediately is at rest. Now, as the person starts walking around, the classification shows that the person is walking. That is also reflected on the GUI as the green box. Now, it also shows that the person is at rest right now, and the location is also visible there as the person is in the room. Now, while the person is going to bed right now, the classification shows that it is on bed, and the timer also launches showing that the location of that particular person is on the bed, and the timer is also running. Because the person is at rest on the bed, the classification also shows that the person is at rest, and the timer keeps running. Once he gets up, the timer stops, and it shows that the person got up from the bed and is at rest.
Now we can see the person 2 entered into the frame, and person 2 is represented as the yellow cuboid in the GUI. And we can see as person 2 is walking, we can see yellow walk is being displayed on the GUI. And now the person is at rest. We can see that is updated in the GUI as rest. Now person 2 is sitting down on the chair, and the timer starts, and we can see the GUI sit down, and the timer tells about since when the person 2 is on the chair. And now the person 2 is resting, so we can see that. And now the person 2 stood up, and we can see the GUI update that is stand up, and the person 2 is resting. And now the person 2 started to jump, and we can see that yellow jump is been updated in the GUI.
We can also see that green person is also showing as jump, which is literally the case.
So using the mmWaveRadar sensor, we have built an application to simultaneously localize and do activity classification of 2 people. And we have shown the demo for the same. Thank you.